Lesson 11.4 deals with adding and subtracting rational expressions. We're still talking about expressions, so we're not solving, we're just combining and simplifying. Alright, so first we're going to talk about the nice easy ones that have common denominators. Common denominators, really simple, really nothing new that you're going to learn here. It's just a matter of applying rules you already know. When we get to not having common denominators, those ones do get a little tougher. But when you see a common denominator, there are just some basic rules you have to follow. So first we're going to look at adding. Adding is always a little bit easier because you don't have to worry about that negative being distributed. Adding with like denominators. And the main thing is that it's just like any other fraction. So your denominator stays the same, you just bring it over as it is, and then you combine your numerator. Only difference is with combining your numerator or your numerators, you can only combine like terms. So you might end up with a polynomial in your numerator, and that's okay. So denominator is the same. And numerator, you're going to combine like terms. So I'm just going to go through two quick examples like that so you kind of see them. Example 1, we'll do 1a. Tells you to add 2 over x plus 3 and 5 over x plus 3. So since you have a common denominator, you're just going to have 2 over x plus 3 plus 5 over x plus 3. And your common denominator comes over as an x plus 3, and your like terms are 2 plus 5, which is 7, and you're done. Okay, so everyone probably thought that was pretty easy. Don't overthink some of these, just apply the rules you already know. Okay, this one just shows different like terms. If I had 5n over n plus 1 plus 2n over n plus 1 plus 3 over n plus 1. First thing you look at, do I have a common denominator? And you do. So because you have a common denominator, you go ahead and you bring n plus 1 down. I'm going to use a different color so it's easy to see. And now you're just going to look at your like terms. You have 5n plus 2n plus 3. You can only combine the 5n plus 2n. So you have 7n plus 3 over n plus 1. 7n plus 3 can't be factored. It doesn't have a common factor to pull out, so you don't have to worry about simplifying any further there. And that's your final answer. Can you cancel those n's? I hope everyone said no, and I hope you all said no because this is a binomial and that's a binomial. And in order to simplify a binomial with another binomial, they have to be exactly the same. Only way you could have done that is if these were monomial factors pulled out of those binomials, which they aren't. Okay, so now we're going to step it up a little and do an example that's a little more difficult. This one's a subtraction example. It's going to show how to subtract the polynomials, or the rational expressions, but it's also going to show you taking it a step further and simplifying when you need to. You've already been simplifying in lesson 11.1 and 11.2, so that won't be anything new. It's just making sure that you do it when it's needed. All right, example 2. Asks you to subtract. We're going to do a few of these examples. So the first one, 2n plus 1 over 2n squared plus 5n subtracting 3 from 3n plus 4 over 2n squared plus 5n subtracting 3. So the word from, you need to be very careful because you're subtracting this from that. Language that you have to be aware of. Hopefully some of you have already realized what that means. If we're subtracting this set, this rational expression from this one, then when we actually go to write this as a subtraction problem, this rational expression is going to come before that one. So that makes the second expression first when you go to actually subtract it. So 3n plus 4 over 2n squared plus 5n minus 3 subtracting 2n plus 1 over 2n squared plus 5n minus 3. Okay, hopefully some of you remember the rules about subtracting polynomials. And if you do, then you remember that in order to convert this subtraction to addition, you're going to need to distribute it. So, distribute your negative. As you distribute your negative, you can combine all these top numerator terms through addition. You have the same denominator, so you're not worried about denominators at this point. So now I rewrite it, 3n plus 4 minus 2n minus 1. Don't forget you're distributing to both. All over 2n squared plus 5n subtracting 3. And now you're going to look for like terms. I have a 3n and a negative 2n, and then a positive 4 and a negative 1. So I end up with n plus 3 over 2n squared plus 5n subtracting 3. So now that you have this simplified here, there's one last step that you need to actually check. Right here, there's a possibility that your denominator has a factor of n plus 3 in it. And you always have to check that final thing right there when you see that something is factorable. So from here, you're going to look at your denominator, and you're going to do the diamond and the rectangle because it's a trinomial and factor it. And it's a trinomial with a coefficient in the front, so you have to be careful. So I end up with a negative 6n squared and a positive 5n. And that means you're going to have one positive and one negative. You should have found 6n and a negative 1n. And then when you go to set up your rectangle, don't forget first term 2n squared. Rectangle is replaced right here with the middle term. So positive 6n, negative 1n, and then last term, negative 3. Pull out your common factors. Common factors are positive 3, n, 2n, negative 1. So now you're going to rewrite this as n plus 3 over 2n minus 1 times n plus 3. And you're going to check to see if they have common factors, and they do. Hopefully you all saw a common factor of n plus 3. So n plus 3 and n plus 3 cancels, and your final answer ends up being 1 over 2n subtracting 1. These ones don't cancel, remember, monomial, binomial, and you need the 1 in the numerator to keep this as a fraction. Now, if this was not a common factor of n plus 3 here, then you would have just left that as your final answer. You wouldn't have written it factored here. So you try your diamond rectangle or pulling out your common factors, and if something simplifies, you simplify it. If you don't, you just leave it like you were right there. So let's write some information on the left to help you later if you run into any trouble. When you're subtracting, with like denominators. Now, the example I just showed was in a subtraction problem over here when we had to simplify further, but it's going to happen with addition problems also. I just didn't make them harder at the beginning, so you kind of saw the pattern, but you are going to run into some where you do need to go ahead and factor them. And try. Like in this one right here, I knew I probably needed to go ahead and try to factor that eventually to see. But when I was looking at these, only a common factor could be pulled out. There weren't any. Okay, so first thing you need to remember is to distribute the negative to the polynomial being subtracted. Not to both of them, just to the one that's being subtracted. And make sure you have the right one. And you're looking at your numerator only. If you were to distribute it to the numerator and the denominator, then you would actually end up flipping all the signs perfectly so that it never was distributed, because every negative would cancel and become a positive again. Then you're going to combine like terms, just like you did on adding. Remember to watch your order. When you see from, you're going to have to flip it around when you see from. So second expression goes first. And then the big thing is, and this is for addition and subtraction, always factor and simplify if needed, like we did in this last one. Now we're going to get into the ones that are a little more difficult. These are the rational expressions with unlike denominators. Same rules are going to apply with your numerator as far as combining things, whether you're adding or subtracting. Only difference is you're going to need to get a common denominator, and that takes an added step or two sometimes. So this is example 3, and it would be hard for me to show examples of every single type that you're going to come across. So you're just going to have to really keep practicing them and trying all the different varieties of problems you're going to come across. But it's the same general rule every time. So this is example 3. It asks you to add 2 over 3x plus 1 over 6. First thing you have to get good at is just finding your least common denominator, or your least common multiple between your denominators. And in your homework, they're actually going to ask you just to find that sometimes, just to practice getting ready to be able to do this. But I'm just going to go ahead and show you how to do it right in this example here. So all you're going to do is just take your two denominators, and you're going to write them down. So I have 3x and I have 6. And you're going to look for the first, if they were binomials, a little different, but we have monomials here. First number, first variable that they each can become. And if you notice, 3 goes into 6 and 6 goes into 6, so it would be 6 and then x. So your goal is to go ahead and get each of these to be a 6x. So now you need to figure out what you're going to need to multiply this fraction by to get it to be 6x, and what you're going to need to multiply that fraction by. So if I have 2 over 3x, what am I going to multiply that by to get it to become 6x in my denominator? Hopefully you all figured out it's 2 over 2. Remember, you're always multiplying by a value of 1. So numerator and denominator, you need to multiply the same thing. So this one is going to become 4 over 6x. And now you're going to do the exact same thing to the other term. We have 1 over 6, and we need to multiply that by x over x. And when you multiply that by x over x, you get 1x, or x, over 6x. Now you have common denominators, so now you can go ahead and add them. So you rewrite it, 4 over 6x plus x over 6x, and now you're following the rules that we just were doing a few minutes ago. Denominator comes over. These aren't like terms, so I'm just going to add them, 4 plus x. And there's my final simplified expression. So this is when you've got monomial factors down here. When you have a monomial in your denominator, they're a little bit easier because you've spent a lot of time finding least common multiples of monomials in the past just by simplifying them. Now we're going to look at a polynomial denominator. Actually, we're going to write a little bit about monomials first. So, monomial, unlike denominators. You're just going to find the LCM, convert each fraction, and then simplify. And I knew this wasn't factorable because of monomial and a binomial there. And the binomial didn't have a common factor to pull out. Alright, example 5. Add 5 over c plus 2 and 6 over c subtracting 3. These are actually fairly easy if you think about it, because c plus 2 is a binomial, c minus 3 is a binomial. All I can do to find their common multiple or common denominator is just multiply this one by c minus 3 and multiply this one by c plus 2. So my LCM is actually fairly easy because your LCM is just c plus 2 times c minus 3. That's all you're going to be able to do there. which means that I'm going to end up with my first fraction, 5 over c plus 2. That's going to need to be multiplied by c minus 3 over c minus 3. And there's a reason I have parentheses. Hopefully you all know why. And you should know why, because you know you need to distribute there. So you actually end up with 5c minus 15. These you can go ahead and leave as binomials. You don't have to multiply them out. But if you were taking a test where the numerator was actually written in form of multiplied out, you would have to go ahead and use your rectangle or FOIL or distributing correctly to go ahead and multiply those out. But in terms of this homework, really nice thing, you're just going to leave them in that form right there. So I'm just going to bring over c plus 2 times c minus 3. The reason I'm multiplying this out is because, remember, my goal is to combine all my numerators together. So I'm going to need to see what's a like term. Okay, then I'm going to convert my other one, which was 6 over c minus 3. And that one I multiply by c plus 2 over c plus 2. And I'm going to do the same thing. Distribute 6. And I end up with 6c plus 12. And then these just come over. You can write them in any order, it doesn't matter. C plus 2, c minus 3, if you want to see that as the exact same denominator. Commutative property allows you to multiply those and flip them. So now you're just going to write all these, the numerator terms. So I have 5c subtracting 15 plus 6c plus 12. Remember, I'm adding. These were add. If this was subtraction, I would need to distribute subtraction to each of these. So be really careful when it's subtraction. Over c plus 2 times c minus 3. And someone else might have c minus 3, c plus 2. There isn't a right or wrong there. But now I do need to go ahead and combine my like terms. I have a 5c and a 6c. And then I also had a 15, or negative 15 and a positive 12. So I end up with 11c minus 3 all over c plus 2 times c minus 3. And hopefully everyone knows those 3's don't cancel because we have a binomial and a monomial there. Actually, sorry, binomial and another whole binomial. Now, if this top piece was factorable, the numerator, if I saw a common factor that needed to pull out, I would check that because there's a chance that maybe c minus 3 would cancel. It doesn't, though, because nothing comes out of 3 there. Okay, I'm going to put one more of these down. I want you to try one on your own. Do the same thing we did before. I want you to try it, and then hit pause while you work on it, and then hit play and check it. Okay, first one I want you to practice is the monomial. So 3 over 7y to the 4th plus 2 over 3y squared. Go ahead and try that now. Hit pause when you're done. Check it. Alright, so the first thing you should have done is looked at your denominators to find your least common multiple here. So the least common multiple between 7 and 3 is 21. Y squared and y to the 4th would be y to the 4th. Remember, you're always going with your higher exponent here because you can multiply y squared up to be y to the 4th. Can't multiply y to the 4th up to be y squared. So I was looking at your highest exponent of each there. Now you're going to convert each of these. So 3 over 7y to the 4th times, I needed a 3 and a y, no y at all, so 3 over 3. And I have 9 over 21 y to the 4th. And I always actually multiply that out to make sure I really get what my goal was there. Okay, now I'm going to try the next one. So I have 2 over 3y squared, and I'm multiplying this by something to get it to be 21y to the 4th, which would be 7y squared. 2 times 7 is 14, so 14y squared over 21y to the 4th. And again, I checked it to make sure. Now I'm ready to combine them, and I'm just adding. So I end up with 9 plus 14y squared over 21y to the 4th. There's no like terms here, so I can't do anything. And there's no common factor to pull out, and this is not a difference of squares or anything like that. This is fully simplified and combined. So I'm done. Alright, now try a binomial one on your own. Same thing, I'm going to write the problem down, and then you go ahead and hit pause, try it, and then hit play when you're done. This is practice number 2. 5 over t plus 4 plus 3 over t subtracting 1. Hit pause now. Alright, hopefully you tried this out and you were able to do it. First thing you did is found your LCM. Your LCM should have just been t plus 4 times t minus 1. That's all you're going to do when you have two binomials like that. Now we're just going to convert our first fraction, which was 5 over t plus 4. And we needed to multiply that one by this binomial. So t minus 1 over t minus 1. And you distribute, don't forget to distribute, and you have 5t subtracting 5 over t plus 4 times t minus 1. So there's your first fraction. Now you look at your second one, 3 over t minus 1. And you had to multiply that by t plus 4. Don't forget to distribute, and you end up with 3t plus 12. Again, now you have your common denominator of t plus 4 times t subtracting 1. And now that we have that, we can just combine all of our terms through addition. Some of you might just start to see your steps here. Be careful if that was subtraction, though. If that was subtraction and I was going to combine from here, I would go ahead and change these signs right now before I did that. But now I can just look for my like terms. 5t plus 3t is 8t, and then negative 5 and a positive 12 is a positive 7. And then again, it's all over t plus 4 times t minus 1. And I'm going to look here to make sure there's no common denominator, or I'm sorry, common factor to pull out, and there isn't. So this is done. We'll try more in class, and when we work on the ones in class, you'll start to see that there are a lot of them that are factorable. There's a lot of different variations, but you just have to keep working with all the rules you already know.